to have a conversation about how we look at data and how we observe certain things that we can do with it. And for that, we need to start with a very uncomfortable part of the statistics class, which is called the English lesson. We're going to need to do vocabulary. The reason why we're doing vocabulary is because commonly used words have a very different meaning in terms of statistics and in terms of mathematics, right? And in terms of common language. So, for example, data. How do we define data? Well, data is any observation that we can collect. Anybody ever traveled off the island, right? When you fly back, there's a little questionnaire. Where do you live, right? Are you bringing any money? Are you bringing any seeds, right? What's your favorite hair color? Do you like bubblegum, right? This is data. All of it is data. So we have this. Let's start with data. So that's any observations we can collect. Then we have the word statistics. Statistics will have two meanings. The first one is the discipline. And the discipline talks about collecting data, summarizing it, drawing conclusions from information. And that's what we're going to try to do. And that's statistics. Now, when we start to talk about collecting data, we need to start collecting from where? How do you answer questions, right? If it's just you on the lonely island talking to yourself, it's kind of awkward, but you're still collecting data, right? So we collect data from two places. One is called the population, and one is called the sample. Population refers to the complete set of items. So for example, population of this class is all of you and me. Population of the school is everybody that attends the school. Population of the United States is the 315 million of citizens, residents, and immigrants, right? The whole thing. That's population. Well, populations, so that's the complete. In the future, I will write just pop. So mind you, there might be short notation for it. And then we have sample. What's sample? Sample is a little subset of the population that is smaller and may be easier to deal with. For example, sample of this classroom could be people sitting in the first row. It's a sample. It's a subset of the population. And the reason why we're doing it is we are hoping that the sample will reflect something that happens about the population. Sometimes you get lucky, sometimes you don't, right? All of us have an auntie that you ask her and she is like the average of everybody else in the family. Like absolutely average. The hair color is average, the height is average, the weight is average, the income is average, right? She even likes both cats and dogs, right? That's a good pick. But on the other hand, you look at the street I live in and you pick me. I'm from Europe. Not even mainland, I'm from Europe, right? White is sour cream, not a single piece of gene that is Hawaiian in me as far as I can tell, right? And you assume the whole street looks like me, you might have misplaced your trust in how good your sample is. So there's the sample. Samples are easier to deal with because they are a subset of the population. But we sometimes have to deal with the whole population. And when we're dealing with the whole population, we're using something called the census. Census is what? Census is collection of information or data from the whole population. Anybody has an example of when we do census things? Oh, so you're talking about actual population. Every 10 years we hire, what, 25,000, 30,000 people, and they go out, knock, knock. Do you live alone? No. How many people live in your household, right? Kind of thing. And we collect it. Why do we do it? Well, because we want to have the raw data. We want to know exactly how many people live where. And they still get it wrong. But, they're trying. Any other place we do a census.
What's the difference between the census and a population?
Population is a set of, for example, individuals. Census is saying we're going to collect data from that population. So a census is the collection of data from a population. Population is a set of, for example, variables. So a census is just asking. So where else do we use a census? Guys, it's a 300 level class. I'm assuming all of you are like snappy, so not all of it at once, one person at a time. Where else?
Student registration.
Sure. Student registration, we want to account for every student. Sure, that works. Anything else? How about prisons? Head count. Anybody try thinking of a prison where you don't do head counts like every 5 hours? It's like, we house the criminally insane and we check the population. We do a census every 15 years. We're hoping we're getting it right. Right? So census is great. The problem is census deals with the whole population. When we're talking about a student registration, right, we have 20,000 people. Right? Talking about a prison, 8,000, maybe bigger. You're talking about the United States, 315 million every 10 years, and we still get it wrong, right? But this is getting big. So census becomes problematic. All right. So we lean towards, let's try picking smaller groups and seeing if the whole behaves like the smaller group or the small group behaves like the whole. Right? So we're trying to take a sample. Any examples? Student evaluations. Sorry?
The Gallup poll.
Sure, for politics that's a pretty good one, right? But for students, it's student evaluations. I'm hoping that people that write my evaluations aren't people that really, really hate me or really, really love me. I'm hoping I get some of the people in the middle of the road, like, he's okay, but he could be funnier, right? Or who could be assigning more homework or less homework, right? I want to get to know. So we try to do this, pick a sample. So pick a sample. But the problem is, how do you do it, right? You seem to be laughing at my jokes. Maybe I ask you how funny my jokes are. Seems legit, right? Is her opinion going to reflect everybody else's? Maybe. Yeah, I'm hoping everybody's thinking, right? But we need to get the sample, so pick a sample randomly. And that's the biggie. Randomly is the biggie. Random means, for the most part in this class, random means that every member of the population has an equal chance of being picked. So if I had to pick somebody randomly in this classroom, I would take index card, put your name on each index card, toss it in a big hat, and pull one out. Everybody has the same chance of winning, right? Lottery kind of numbers. Bingo numbers. Well, this is the type of random we're talking about. Because if we start skewing this, and I start going, hey, so what do you think? Right? That's not random. That the opinion could get skewed, and that's not very good, right? Go in the middle of Texas and ask somebody who is a declared Republican who they vote for in the next election. The outcomes are predictable, right? But I pick random people from the great state of Texas randomly, I might get slightly more colors to my palette, not only red. All right. So once we pick a sample or a population and we start to collect things from it, we have to name things we are collecting. So we have two terms. We have a parameter and a statistic. So parameter refers to a characteristic of a population. Example? Sure, right? 30% of Oahu is white. Right? It's a characteristic. So I'm talking about a parameter. But I can also talk about a statistic. Right? I can talk about a characteristic of a sample. I'm going to walk through Waikiki. I'm going to pick randomly 50 people, and I'm going to ask them about their ethnicity. Right? It comes out to be, let's say, 85% white or 80% white. And you suddenly go like, okay, well, that's a statistic. So when you start talking to me about a parameter or statistics, I know where you're getting the data from, right? parameter comes from a population, and statistic comes from a sample. Okay. All right, so now we know what we are picking from where. So what's next? Well, we are all at least 1 year old, so we done a survey before, right? We all done taxes before too, right? Right? Taxes have two questions that are very common. One is, what's your gender? Because we want to make sure that we got that one right on the records. And the other one is income, right? I'm a male and make $30 a year, right? So we look at those two, and those two pieces of data that we're going to get are very different, right? One is qualitative, and one is quantitative. Quantitativa. This is mostly a category. And by being a category, it's mostly non-numeric. Hair color, eye color, right? Position in the family, are you head of a household, are you dependent? Right, so this is a non-numeric category, gender. And then you have qualitative, which is a numeric value. How tall are you? How heavy are you? How much are you making? How many fingers am I holding up, right? We run into an interesting thing that if we look at qualitative, non-numeric things, we still can have numbers in it, right? We can still have categories that describe an answer, but those categories are non-numeric. What does it mean to be numeric? What's the difference between 1 for male, 2 for female, right? Those two numbers, and I have 1 brother versus 2 brothers. What's the difference between those 1 and 2s?
One is a selection, the other one is a quantity.
Yes, right? If I take 1 for males, 2 for females, a female minus a male doesn't give you a male. Yes? So in here, math, mathematical operations are meaningless, right? Even if I have a number, I cannot do anything with that number. And in here, math works. Right? So we're getting into that. All right. Can we provide some examples of qualitative or categories that are non-numeric but are actual numbers? Numbers you cannot do math on. And I know that I think there's at least one example in there. What's the example in here?
Phone number.
Phone number, yes, because your number minus number, and my number doesn't give her number, right? Or the other way around. Your parents' phone numbers added together don't give your number, although that would be kind of creepy, right? NSA for the win, right? What else? What other numbers do we have that we cannot do math on? Mom, no?
Addresses? House addresses?
Sure. In most cases, you know, if you live on 1272 and somebody next to you lives on 1252, that 20 doesn't do anything. Okay, street numbers, sure. What else? Social security numbers, of course. Your number minus your kid's number doesn't give your wife's number, for example, right? So social security, what else? There's one really good one. Has 5 digits to it. Zip codes, right? New York is 10072, I think. So what's the local zip code? 96827 or something, right? Minus 1.0072, which is Manhattan. Oahu minus Manhattan doesn't give you, well, it actually gives you, I think, Nebraska, Oregon or Nebraska? Oregon, I think. And then Oahu minus Washington, D.C. gives you Nebraska, I think. I played with it a little bit. Right? It doesn't make sense. Aside of the fact that, Washington, D.C. and Oahu is middle of nowhere. But, point taken, right? So we have a bunch of things that are categories, aren't numeric, are numbers. But we cannot do anything because the defining parameter is this. This question of can we do math on it or can we not do math on it? Yes?
Actually, zip codes do make sense.
Well, they do make sense where they are placed, yes, but you cannot subtract zip codes.
Right? If you do that type of math, but other math is you can do the distance from the zip code that's assigned to the state. It starts from the first
Yeah. Okay. Yes, but that's a. I heard about it, and I don't know. I don't have it confirmed, but yes, but that runs into the problem of very specific case for very specific reasons, right? Social security numbers give you a specific distance from the date of birth too, but I need to do some twisting around to get it. I cannot just go one number plus the other number. That's meaningless, right? License plates, yes, there is a meaning behind certain license plates, especially, for example, delivery trucks, right? They have this license plates and they have this special number, and you can say, hey, this truck was purchased as the 5th purchase, right? But if you look at the actual license plates, which is right, doesn't mean anything. So the question is, can you do math operations? And again, I squint my eyes because on most numbers you can do certain additions, just they are meaningless in the grand scheme. I appreciate the difficulty though. I'm on to you. Well, yeah, because here the mathematical operations are meaningless, and here the mathematical operations are meaningful. All right. All right. So, since we're talking about numbers, let's talk about numbers. May I ask how old you are?
Huh?
May I ask how old you are?
How old?
Yeah, may I ask that question? Okay. 23. You sure it's 23?
Yeah.
Okay, good. Are you sure it's exactly 23?
Yeah.
So your birthday was, and 5 seconds ago. Lies. The chances of that happening are slim. On the other hand, you ask my niece how old she is going to say 4 years, 2 months, 3 weeks, 4 days, 7 hours, 14 minutes, 17.25 seconds. That's what she's going to say. She's very good about it. She's like, I learned numbers. I know how the watch works. She has one of those fancy watches with atomic timers, right? So she's on the spot. And this is how she pronounces her age. Every time you ask her about her age, she's like, no, don't. I'm 4 years. 7, right? There is something very different about those two numbers. How precise is this number? Well, yeah, but for that split moment, now kind of thing, right? How precise is this number? It's pretty precise, right? So now the question is, you're saying 23. So we assume that you're somewhere between 23 and 24. I'm not going to age you too much, but I'm right. How many possible birthday times, according to this method, are there between 23 and 24? Yeah, sure. Sorry?
Depends on if you measure the difference between 23 and 24 by months, days, weeks.
Oh, right?
By seconds.
Right? I can go into a fraction of a second, right? So the difference of how many numbers I can squeeze between 23 and 24 is how precisely I'm measuring, right? Have you ever wondered how thick a piece of paper is? Right? It's a fraction of an inch, or a fraction of a tenth of an inch, or 128th of an inch, right? You can but the precision of how close you get to the actual value is based on how good your measuring tools are. I'm assuming if my niece got one of those cesium clocks with actual counting of vibrations of the atom, she could go with a couple extra zeros here, right? Which means that between 23 and 24, we can squeeze a lot of things. And that leads itself to this conversation about quantitative data. We have data that is discrete and data that's continuous. Discrete data is like counting eggs. You go to a store and you buy a dozen of eggs. How many eggs are you expecting? 12, right? But on the other hand, you go to a store and you want to buy 1.74272571 pounds of eggs, you're going to be hard pressed to be able to do that, right? Your height could be a piece of discrete data. I'm 60 tall. Or I could get it really, really precise. So we're talking about two data that can be divided into discrete, where we have a quick count, how many fingers I'm holding up kind of thing, right? Nobody's going to say, well, the middle one looks a little short, so probably like 4.8 fingers up. No, it's 5 fingers, right? Right, or 2 fingers, right? You don't go to a bar and go 2 fingers, and the guy comes out and it's like, that looks like a finger and a half, right? You want 2 fingers of whiskey, you're getting 2 fingers of whiskey, right? I want an ounce of liquor. I want to bake something, so I'm going to use 2 pounds of flour, right? This is very precise. That's discrete data. And then there's continuous data, where things aren't exactly spot on, right? Think about measuring things. Anybody did carpentry before or put an IKEA desk together? If you ever did, have you ever noticed that the screws are sometimes just notch off, and things that's supposed to be flush are just like there's just something that will stop the quarter from sliding off and just annoys the living crap out of you? Or you buy a shirt and the back parts of it are sewn just little off. Like I have a Aloha shirt that somebody decided they want to keep the pattern versus the shape of the shirt. So it looks like this, one of the things. This is the difference, right? Discrete data is countable data, things that we can do on our fingers. We divide things into increments we can deal with. Continuous data says, hey, age, I can look at age as continuous data, and depending on how I slice it and how precisely I can slice it and how precisely I can measure, I can get very, very different answers. Okay? So we have 2 types of data that's discrete, which is countable, and uncountable data, because there's just so much of it. Okay. All right, so now we have qualitative, we have quantitative, we have discrete, we have continuous. We're so excited. And now comes the question of, well, we're going to be measuring it, right? We're going to somehow be collecting this data. And this data has to come in ways we can put it into little bins of how precise the data is, right? If somebody comes around you and asks you about your favorite color, is this a valid data point? What's your favorite color? Red. Yours?
Blue.
Red. Excellent. I'm going to start making a chart and listing how many people like red, how many people like blue. What color do you like? We only go red and blue, right? And I can collect this data. Is this valid data? Yes, it is very valid. So we start looking at data. The first category is actually not. Let's call the title for it. So 4 levels of measurement. 4 levels of measurement. So the first one we're going to call about nominal. Nominal. Right? So nominal measurement says, hey, I'm going to collect categories. You cannot rank them. You cannot do anything, but we can collect categories. So favorite color. Religion. despite popular belief, we cannot rank religion. I mean, don't take me wrong, neo-Nazis are trying. You see the outcomes. You cannot rank religion. And I will have a long conversation with anybody who thinks that we can rank religion. We cannot rank religion, right? So this is categories with no ranking. If you cannot read what I'm putting on the board, just let me know. And most of it should be in the book I gave you as well, just in case you want to. All right, so nominal is categories with no ranking. I have a favorite color, religion. Can anybody give me another example?
Eye color.
Eye color, great. Well, that's color too, but okay, sure. What else? Any of you have animals? I do. I have a younger brother, but you know, cats or dogs, right? That's a category. You cannot rank it. Okay, ice cream, right? Mochi flavors, right? There's plenty of things we can do that we cannot rank. I know you try. I can see you, but you know. All right. Then there's ordinal. Ordinal is saying, hey, we have categories and we can rank them, but the difference between the ranks are meaningless. Example, anybody been in middle school science fair? Right? There's a winner, right? There's a second place, there's a third place, but everybody wins. We're not going to tell you that the first winner is way smarter than you are. They just got the first place, you know. They smiled better, right? So those are categories which we can rank. And difference. And difference between ranks are meaningless. Can anybody give me another example? Something that we can rank, but we cannot tell the difference between the ranks.
Like favorite ice cream?
Well, you cannot rank ice cream flavors.
Best song. Because they have like a chart that ranks it from like 1 to 100.
Sure, best song, unless you put the number of people voting for it. Right now, if the more you put number of votes, you can rank it. But if you just have a blatantly favorite songs, right, 10 best video games, then yes, right? But again, you have to be able to rank it without actually doing math. Yes?
Beer?
Beer? No, you cannot rank beer.
Military ranks.
Military ranks. What is a general minus a major? It's a second lieutenant, all right? Right? And then what's a private minus a general? A civilian, right? We can play this game. We can categorize them. We can rank them. And if you don't, ask one of your friends that is military and see, right? But the differences between the ranks are meaningless. First lieutenant minus second lieutenant doesn't do anything, right? Doesn't tell you anything, especially since if you could rank in the military based on the number of years, every year you get promotion, then we could talk about the difference between ranks making sense, but we can't. Sometimes it takes you 2 years to become a captain, sometimes it becomes 5. Sometimes you never make it, right? So that's differences are meaningless. All right, so after ordinal, we have interval. Well, interval is categories. We can rank. Differences make sense, but no zero. But no zero. There is no natural zero. Example, swim meet. We're going to look at people that finished a swim meet. We can rank them Yes, there are categories, right? Jake, Susie, Adam, Samantha, right? We can categorize it. We can rank it. Yes? He won first place, she got second, she got third, he got fourth, right? The difference between those ranks is meaningful. He was 30 seconds faster, she was a minute faster, right? It's meaningful. Is there a zero? No, there's no natural zero, right? You cannot get it. For people that don't do science, temperature in Fahrenheit is the same way, right? You can rank temperature. This is hotter than this or colder than this, right? You can rank it. The difference between those temperatures makes sense, right? It was 98 yesterday, now it's 88, 10 degrees, right? We can make sense. And there's no natural zero, because zero is just another rank between the list. Now, if you're a scientist, you know about absolute zero, and the whole thing goes out of the window. I'm an engineer, so I know, don't use temperature. I'm just saying, right? But interval is another way of looking at collection of data, right? And then the last one. Oh, the last one is called the ratio. And ratio has all the flavors of the ice cream. It's a category. We can get categories. Categories. You can rank. Check, check. Differences. Okay, right? Differences make sense. And there's a natural zero. So you have all four things. Example that I stole from somebody else is your bank account. 5 grand in your bank account or 4.5 grand, right? You can rank it. More money, less money. The difference between the two makes sense. It's 500 bucks, right? And what's the last one? Natural zero, right? You pay rent, you pay child support, you buy a case of beer, and you're left with zero. There is a bottom line. So there is the natural zero. So bank account is one of those. So if you're looking at, for example, income, you're looking at the ratio, level of measurement. Is everybody comfortable with the information I pumped into you today? So far, so good. Good. All right. We not always want to deal with the whole population while we want to talk about the population, right? We want to talk about Americans and American citizens and the great country and 315 million of people without asking 350 million of people. It's kind of inconvenient. It's just every time you want to find out something, you have to go ask 150 million people, right? How many of you will ask for direction if you get lost and your phone is out of charge? Like if you ask once, maybe twice per road trip, you're like, by the third time, you're like, maybe not. 350 million times later, right? So we take a sample, right? And we take different samples, and we take samples all the time because it's easier than to ask everybody. We ask a little piece. So for example, right, how many of you took a selfie and was like, do I look cute in this picture? Right? Or, you know, you buy a new pair of jeans and go, does this pair of jeans make my ass look fat? Right? And then what do? Well, most of people look at their own ass and be like, well, I'm okay with that. You know? I bought a pair of pants recently. It's like, yeah, I can pull that off. Right? If you feel a little bit courageous, you go and post it in private, friends only on Facebook, right? If you're feeling a little bit more courageous, you do Instagram. And then if you really, really want to have a bad day, you go 4chan or Reddit, right? Statistics is not going to be your primary tool for work, period. Let's not have illusions here. It won't be for... What will make you spectacular is being able to spot falsities in things that are presented to you. There will be an underwriter, somebody who crunches the number, and they will present this sparklingly beautiful report with a bunch of tables and charts on it. And your job is to make a decision based on that. So what I'm trying to teach, more than you are capable of crunching numbers, right? Unless you're in your 20s right now, early 20s right now, and you're on a fast track to get a math degree, you're not going to be crunching numbers very heavily, right? Nothing beyond Excel. But what you need to understand is you need to be able to take a look at a report and come up with a conclusion. There's a famous joke about statistics in New York. There are two statistics in New York. Half of the people speak Spanish in New York. And half of the people in New York State cannot read and write. So somebody brilliantly put the statistics together. Half of New Yorkers speak Spanish, the other half cannot read and write.
So people speak two languages.
You're getting into the point on the side, right? The point is you get things put together and you don't know how it comes out, right? Have anybody heard about the statement, I'm going to put 110% effort into it? It's a fallacy. And your job is to be able to spot those, right? Beyond college, your ability to crunch huge numbers goes down very quickly. And I can try to teach you that, just I don't see the point. For me, it's more important for you to have the mental set that you can do it and learn and teach yourself new things, right? And again, I understand certain frustrations. I understand that I'm repeating myself. But